Hi, everybody. Thank you for joining us today for our November Career Cafe, Careers in STEM. And today we have a special guest speaker, Dalton Echard from Anton Paar. I am Mrs. Corbin. I'm the career counselor at Hanover High School and Mechanicsville High School. And we also have Mrs. Edwards with us today. I'm gonna let her say hi.
Hi everyone, thanks so much for being here. I'm Mrs. Edwards, your career counselor with both Atlee and Patrick Henry High Schools, and thank you, Dalton, for being here with as well. We're excited to have Anton Paar here.
And today during the presentation, if you have questions, if you want to just go ahead and put them in the chat, and then we will make sure that we get to them by the end, and we'll have some Q&A at the end of the presentation. So I'm going to go ahead and hand this over to Mr. Echard, and he's going to get us started. Thank you.
All right, thanks, April. Thanks, Shannon. Again, my name is Dalton, and I work with a company, Anton Paar, and I run the apprenticeship here. So what Anton Paar actually is we're a scientific instrumentation company. So all of you out there who are interested in science, engineering, or any of the STEM category type disciplines, this is definitely the opportunity for you. So I want to just get into basically what scientific instrumentation is. I have a brief presentation for you to talk about what the apprenticeship is, dates to remember, and ultimately we can take a little tour around the lab where I'm currently standing and see a bit of the technology that I get to work with frequently and many of our apprentices do as well. So scientific instrumentation, this is probably a word that might not mean too much to you at this point. You hear instrument, you probably think like a cello, and you think science, you probably think, I don't know, like periodic table. But what scientific instrumentation is, you put the two words together, it's actually means measuring things. And when I say measuring things, you've used scientific instrumentation before if you've used a ruler or a clock. A ruler measures length, a clock measures time. When you want to measure something more complicated though, something maybe say density or viscosity, that's where we come in. So if you're interested in learning more about how things work and how actual scientists measure the things that we're using every day, this is definitely an opportunity for you. So I'm going to do a quick share of my screen, show you a little bit more about what the program entails, and then again, we'll get to the lab tour. So let's do. All right, so our logo here should be popping up. We're very much into our company colors of that kind of crimson red and gray. So let's get started. All right, so Anton Paar's solution portfolio. These are a lot of words that are probably very foreign to you. I said density and viscosity before because they're terms that might be a bit more familiar, but what does tribology mean? What does polarimetry mean? What is physisorption? These are probably terms that you've never heard before, and just a list of them doesn't mean all that much. Well, these are the values that we use our technology for to measure. But what does any of this mean? So admittedly, this slide, not too important, but what this slide results in is incredibly important. These values are the things that give your day-to-day experience, well, makes it more pleasant. So let's talk a day in the life of Anton Paar. And I'm not talking about like what an employee does. I'm talking about what actually you've done that we've helped, you just have never seen before. So let's say you wake up in the morning and you're having juice. So if you look on the side of your orange juice carton, maybe you've seen sucrose, fructose, glucose, corn syrup. These are all different words for sugar, but they're all different for some reason. We measure the type and quality of sugar in something like a beverage. So if you're drinking sucrose and glucose, they're different molecules, and we can see that these molecules are different and quantify what they are. After you have breakfast, you brush teeth, and you're using toothpaste. So toothpaste has a really familiar look to it. It's squishy, it's soft, it pushes out of the tube. That doesn't happen by mistake. If toothpaste was very liquidy, it would just flow out of the tube on its own. And if it was very solid, you would never get it to move. We've all heard before liquids and solids, like they're two different things. There's actually a spectrum between liquid and solid. You can have materials that have properties of both. And toothpaste is certainly one of those. So rheological measurements are the measurements that are quantifying between liquid and solid. After you brush teeth, you get ready to go to school or to work, and you hop in your car. The fact that your engine works means that you put the right gasoline in it. there's different types of gas, and we can measure different qualities of gasoline. Maybe for diesel fuel or the traditional ethanol fuel, we can see the differences between those. Or the fact that the roads aren't cracking or kind of doing a wavy warp looking shape, that means that they've been tested for being in the right conditions. The asphalt, the pavement that goes down in Florida is different than the pavement that's in North Dakota because there's different temperatures. If it gets too hot for pavement, it might start flowing and become wavy. If it gets too cold, it'll crack. All right, so it's about lunchtime, so you might be experiencing this right now. You pop open a soda, and that soda has that carbon dioxide pop out, the bubbles. The amount of carbon dioxide in there is not a mistake. We can actually measure the amount of dissolved carbon dioxide inside a liquid. We can also get, again, that sugar concentration like we were talking about with juices, and oxygen content. Now, oxygen inside of a drink, for example, is a bad thing. If you ever look on the back of a bag of chips and you see expiration date however long out, that's an indirect measurement of the amount of oxygen in something. The more oxygen, the quicker it goes bad. If you cut open an apple, oxygen is what makes it start to turn brown. So oxidizing something is reducing the shelf life. After coffee, I get a little sleep, or after lunch, I get a little sleepy, so I have some coffee. And different coffee has a different particle size. So if you've ever had traditional coffee versus like an espresso, espresso is smaller coffee grounds. And this is, again, something that we would measure, the size of a particle in a powder or dissolved into a liquid, for example. Then you get home, maybe you ran around a little bit, you got sweaty and you need to wash clothes. We use something called zeta potential, it's a unique one, to measure how well a detergent will work, for example. A detergent is a charged liquid. So if you think charge, you probably think of battery, and a lot of liquids have a charge too. The higher the charge, the more likely it'll be to pull off that dirt. And at the end of the day, one of Anton Paar's most common applications is actually in the adult beverage industry, and we measure the content of those as well. So Anton Paar is actually an international company, but our United States headquarters is located in Ashland, Virginia, just south of that the Bass Pro Shop on 95, about 2 miles. And we have 4 facilities in the United States: Ashland, as I mentioned, then Chicago, Houston, and Los Angeles. A lot of our apprentices electively choose to move to a different facility after they graduate. Again, we're an international company. Our headquarters is actually Graz, Austria. So that's why there's a lot of little bubbles around Europe, because a great deal of our employees are working in that area. Physically, where I am right now, this is our headquarters in Ashland. We actually have a tiny campus of multiple buildings. And on the left, this is the facility I'm currently standing in. This is one of our main labs. So getting another look in there. We'll take a look around one of these labs in a couple minutes. All right, so apprenticeship program. If you're interested in science or engineering, this is a great opportunity for you to learn more about how those are used in the practical world. So this is your opportunity to get involved in something like this. So our goal is to find rising seniors, so current juniors, who are interested in STEM in general. That can be pretty vague. Maybe you're someone who likes chemistry, maybe you're someone who likes engineering, maybe you're someone who just likes technical related disciplines. And our apprenticeship is a 3-year program where we're going to guide you, train you through all the skills that are important, and ultimately lead to a full employment as either an engineer or an application scientist. Now, how the program actually works, if this is something you're interested in, initially there's actually a 5-week, I'll call it interview/internship. This is done over the summer. And during this 5-week program, it's a chance for you to feel out if you like working with a company like Anton Paar, and also for us to see what you got. This is basically a big interview for us to see how well you are, and a big trial period for you to see, hey, do I want to continue doing this for 3 years? Because that might seem like a long time. Admittedly, those 3 years fly by really fast. You're doing a lot of very fun, interesting things. And during those 3 years, you're learning job-related skills, either with the goal of being a service engineer, so repairing these instruments, making sure they're working well, or an application scientist, working with them, doing measurements, working with unique materials. At the end of the 3-year training, you'll have obtained an associate's degree, which is actually paid for by us, and have that full job waiting for you at the end. And there's actually potential to finish your bachelor's degree if that's something you personally desire. The goal here is you can grow from there and move to a different facility if that's something you're personally interested in. I say growth and mobility within Anton Paar. There's a lot of upward mobility in the company. Our current CEO actually was an apprentice himself back about 20 years. Again, if this is something you're interested in, here's some dates that are important to keep in mind. So November and December, we're going to be having open houses for students and parents. The first one will be November 30th. It'll go on for 2 weeks from that point. There's from 3:30 to 5 o'clock, and you get to see the facility, ask questions, learn more about the program in greater detail. These are capped at 10 people per event. Simply, we're just keeping numbers low for COVID. This is also when applications will open. Applications actually open, I think, in about a week. In February, the applications will be due. This is really just a chance for us to see what you as an individual have been doing. There's no formal qualifications to apply for the program. However, we do like to see students that have completed physics and ideally calculus by the time they graduate. Not now, but by the time they graduate. We have little one-on-one interviews in February and March, and ultimately that'll lead up to the summer program. We have 15 students that we choose for the summer program. That's that 5-week program, which is basically your big trial and interview. This program goes from July 12th to August 12th this year, and it's totally preparation for the larger one, the larger full apprenticeship. And during this time, you get a little exposure to the scientific concepts these instruments run on, see what it's like to be a service engineer, work inside of these instruments, making sure they're working correctly. And then a couple weeks to run your own samples, be basically a scientist yourself for a couple weeks. In the end, that 3-year apprenticeship, we accept 5 every year to become our full apprentices, get the free associate's degree, and also the pathway towards a career with Anton Paar. How the 3-year apprenticeship actually works: during year 1, which starts in September of your senior year, you work around 8 hours a week while focusing mainly on high school, of course. Year 2 and 3, you work a little bit more and are working on getting your associate's degree through John Tyler Community College. And after the 3 years, you graduate, ready to work. During this time, of course, we're paying you. This is a time for you to learn, but of course you're earning while you're working. The summer internship pays about $10 an hour. And as you progress through the program, you get paid a bit more, including tuition through John Tyler. And ultimately, when you finish, you'll be starting at about a $40,000 salary. Also with the opportunity to go back and continue your education if that's something that, again, you personally find interesting. And of course, you get to work for a very fast-paced and unique company. We're something very unique for this area, so it's certainly an opportunity for those that are interested in science engineering to get some exposure to this type of work. All right, so that is the quick version. Going to stop sharing now, so you should be able to see my face again. And we're going to do a quick lab tour, see a couple of these instruments, and learn a bit more about what they do and what their purposes are, and ultimately how they affect your daily life. Because some of these things I would have had no clue about why things I experience every day work the way they do. Grab my camera. And hold on just a second while you're floating through the air. All right. So the first one that I want to show you is this big blue guy that's been behind me for a while. This is called a BET. Now, a BET is named after the 3 people that made it, so it's not a too meaningful name. However, what it does is measures the surface area and porosity of complex shapes. So if I told you to calculate the surface area of a cube, you could probably figure that out. If I drilled some holes through it and made it porous, that would be a little bit more challenging. Now, if I had a sponge, that would be very, very challenging. Now, if I had a sponge with pores that are the size of microns or nanoscale, so teeny, teeny, tiny, it becomes nearly impossible. What this does is calculates exactly that. Why does this matter? If you've used a cell phone recently, it has a battery in it. The reason that battery life is as long as it is because it has a large surface area, lots of little pores inside of it. The more surface area I have, the more area a charge can sit on, the more charge, the more battery life. So batteries have just been getting better with time, and this is one of the reasons why. For those of you that are more engineering based, right here I have an open instrument. This is called an auto tap, and what this does is has these 2 plates that move up and down to tap down powders and make it flat and level. It's a sample preparation, so not super exciting, but what is exciting is the apprentices actually get a chance to build these. So on the inside, we have a gearbox, which is going to cause a main gear to rotate, which actually pushes these plates up and down. So you can have the opportunity to build a small instrument like this as an apprentice and get involved in the electrical wiring, mechanical components, every little bit. Taking a look at one of the things that I find most interesting. So I get my extension cord dragging behind me. This is our area for scratch testing and indentation. So we have a couple instruments that are in big boxes, but we'll take a look at one of the open ones right here. This is a nano scratch and nano indentation device. Now what this does is exactly what it sounds like. It tries to scratch or indent small surfaces. So we can probably get a little closer and take a look at what we're working on right now. So there's a little piece of metal you can see right there. Now again, why would I use something like this? We'll talk about cell phones again. We talked about cell phone batteries. We can talk about cell phone screens now. The reason screens are as scratch resistant as they are is because of measurements like this. If you had a cell phone about 10 years ago, you put it in your pocket too many times, it gets scratched up. Now I can like seemingly drop it on concrete and there's no problem. The higher scratch resistance of the glass or plastic on that screen, the better it'll perform for real world applications. So cell phone companies, for example, will use that to do some measurements. Another one for measuring solids is right here. This is a tribometer. So a tribometer measures friction constants. Tribo means to rub. Now, friction constants are the value of basically the force that opposes motion. If I have a lot of friction, I oppose motion. So think ice, low friction, tires on the ground, very high friction. Friction can be good or it can be bad. But if we're talking about cars, there's different applications where I'd want high friction or low friction. If I have high friction inside of an engine, that means I'm building up more heat. So this is actually the sample that would be being measured right now. If I have a high friction inside of an engine, I'd be building up a lot of heat. And building up a lot of heat means poor gas mileage. It means my engine's going to overheat and cause problems. It means a lot of wear of those parts, so they break down. But maybe I want high friction. I want my brake pads to actually stop the car. So this is one of the tools that we would use to measure things like that. Taking a look at another category of instruments, Anton Paar's biggest industry is actually the beverage industry. So things like sodas, juices, adult beverages. And these are the kind of techniques we would use to measure this. Here we have something called a DMA. This is a density meter. Get a closer look at it. And what this does, again, exactly what it sounds like, measures the density, but of liquids. What this does is it fills a glass-shaped U-tube, so we call an oscillating U-tube, and it makes that tube, like I said, oscillate, wiggle up and down. This tube has a finite volume, so we know the volume of it, and the oscillation will change depending on the density of the liquid that's put into it. So I know the density from the volume and the mass that I've just calculated. I can also connect this to other components that would measure something like the content of a syrup that I would put inside of a beverage, or the carbon dioxide that's inside of a beverage. So all these tools that we see on this bench, they are generally related to the beverage market. This big guy here, this is measuring the oxygen content of a canned beverage. So if I have a can of soda and I want to know its shelf life, I could put it in here and it'll measure the oxygen both in the headspace, so the area that there's no liquid in, and dissolved into that beverage. Got a couple more minutes, so we'll take a look at one last category. So over here, we have kind of a unique measurement for Anton Paar. These are our microwaves and Raman spectrometers. So these are actually two different things. Now, microwaves is almost exactly what you're probably thinking right now. When you think microwave, you think that thing you have in your kitchen that heats up food. Now, that's almost exactly what these do, except for now we're talking chemicals. If I add heat or energy to a chemical, I can cause a chemical reaction to happen. And chemical reactions are very important for scientists to create new materials or prepare a material to be measured by something else that I could have mentioned before. Now over here is probably a little different than you might be thinking. These are Raman spectrometers. Now this is definitely a different Raman than you're thinking. It's named after a person and spelled a bit different. But what these do, get the chemical signature of a material. So all materials have a different chemical identity. And by shining a laser at it, that chemical identity can be exposed. So if I see a white powder at a crime scene, is it flour, is it sugar, is it a drug? You might not be able to know by looking at it, but this thing certainly can figure it out almost instantly. All right, so that's a quick lab tour of about half of one of our labs. Now, if this is something that you're finding interesting, you can certainly see a good deal more of this. Oh, let me get my camera back on. You can see a good deal more of this if you come to our open house. Oh no, lost the camera. You can see a good deal more of this if you come to our open house and get to see not only the applications lab, which is where I currently am, but also our service labs where the repairs are done. Let me get my video going again. All right. So I think that's a good time for me to call quits on your little tour. Happy to take some questions.
Thank you so much. We really appreciate the tour, and this information has been very helpful. And a quick question, so the open house, is that for our juniors that are applying for the program, or can 9th and 10th graders attend the open house as well?
Anyone can attend if they're interested. The program is open to juniors or rising seniors now, but if a student's a bit younger and interested for future years, definitely check it out now.
Awesome. Thank you. If anyone has any questions and want to put them in the chat, we can take some questions now.
Coming in the chat. Hey, while we're waiting on that, Dalton, how long have you been at Anton Paar, and have you worked through different positions since being there?
Great question. So I have been with Anton Paar now for about 5 years. I actually started as an application scientist, so one of the positions apprentices could potentially start at is where I started. Then I actually moved into a sales role, so our goal is to sell these instruments to companies that need them. So I did that for a bit, and once we started the apprenticeship, this is where I found myself. So bounced around a couple times.
Yeah. Sounds like a lot of advancement and movement if you want to do that, you know?
Very much so. It's a company that definitely offers advancement for those that are interested and show the right skills.
Awesome.
And interest, of course.
Okay.
Oh, they got sound. Look at that.
Yeah, there you go.